Are we live? I think we should be. We are. Welcome everybody back for another developer live stream. We've altered our name a little bit, called ourselves the Beyond the Algorithm with NVIDIA. This month we're talking about generating reasoning enhanced podcasts with open source AI agents. And I'm joined by one familiar face and one that's maybe not so but familiar. We're joined by Neil, who is a tech marketing engineer. He'll give an intro to Nim, including an overview of what Nim is and trying to get them in the NVIDIA AIPI catalog. And we also have Chris joining us, who is a deep learning developer advocate at NVIDIA. Chris will be walking us through how to build a PDF to podcast agent using reasoning models. But before we get to all that, some of you might or may not know that we have a little conference coming up next month called GTC, GPU Technology Conference. We have our mods in the background. Hopefully can share a link to a discount code, but the registration code is up on this slide. It's from March 17th through the 21st, happening in San Jose, California. So if you can stop by, it'd be great to see people showing up for the event and participating. Jensen's keynote's always a highlight, so it'll be great to have as many folks there participating as possible. All right, so I will just kick it off for Neil to go ahead and speak his piece.
All right, thanks, Zach. Really appreciate it. Yeah, so we're going to talk a little bit about NVIDIA Nim today and some of the things that you can do with NIMs in order to, create really cool applications, use them in sort of agentic workflows, and really take advantage of, all the really incredible stuff that you can do with large language models and with sort of generative AI more broadly. So last time, I guess two live streams ago, I gave a little bit of an introduction to what Nim is in general. And I'm going to do a little refresh on that just in case anybody wasn't here last time. But if you're more curious and you want to get more details, we do have the recording of that previous live stream available on our YouTube channel. And we also have a couple of other videos about NIMs, sort of introducing the product and sort of understanding how you can take them and deploy them and things like that. But yeah, for those of you guys who aren't familiar, Nim is NVIDIA's product for basically taking both large language models and other kinds of AI models and kind of packaging them into a container that has all of the dependencies that you need and has all of sort of NVIDIA's goodness for accelerating these models and making them run really, really quickly and really efficiently and really cheaply. And what you can do with those NIMs is basically take them, download them from our website, deploy them on any GPUs that you have locally or in the cloud or and some sort of data center. Really all sorts of different kinds of GPUs, and you don't have to worry about dependencies and downloading and installing a bunch of different libraries and things like that. So it's super great and a really convenient way to be able to deploy AI models. And so if you're interested in trying out NVIDIA Nim, you can go to the NVIDIA API catalog. And here we basically have those NIMs that we're talking about, hosted ourselves so that you can check them out, play around with the models, sort of see what it's like to interact with them and what the output of those models are. And I showed a couple of examples last time. And so one of the things that I wanted to talk about today is that we have a new model available. Or it's been around for a little while, but it's new since the last live stream, which is DeepSeek R1. This is a really cool model. If you guys haven't heard about it before, it incorporates thinking into its responses. And so basically what it does is it kind of, before giving you your final response, it generates this really long chain of text that kind of reasons through and tries to sort of sort of think about what the final response should be. These models like DeepSeek R1 and sort of other reasoning models are really interesting for a couple of reasons. They're much more effective at sort of at doing tasks that require thinking, that require planning ahead, that require taking multiple steps, which is really key for a lot of agentic use cases where you actually want your large language model to be able to go out into the world and do something rather than just answering questions or giving you sort of really quick responses or summarizing things and things like that. But the other thing to think about with these reasoning models is that they are pretty slow. They output a lot of text before giving you your final response, and so you have to wait for all of that text to be generated before you actually get your final response. So I'm going to just try this out here on our website, and I'm going to ask, how about I'm planning to go to GTC next month. What are some of the ways I can take advantage of the conference? And we can see it takes a little while. It's starting to generate the output. And once it sort of processes things and kind of gets scheduled, we'll be able to see it outputting these thinking tokens, right? So before giving me an answer, it's going through all of this process of thinking about what I said and reasoning about its background information and things like that. And basically the implication of this is that it becomes much more important to have an accelerated runtime, to be able to have something that can run your large language models much more quickly than a sort of a standard runtime running them in PyTorch or in eager mode or things like that. And so that's one of the things that NVIDIA Nim can really help with, because we have all of that NVIDIA goodness, all of those accelerated libraries and all of the dependencies sort of figured out and bundled into these containers. It makes it able to to respond much more quickly than what you would see without Nim, and also to be able to handle much larger amount of concurrent users than what you would see with other programs. So, and here's our response. So there you go. If you're interested in going to GTC, you can check out pre-conference preparation and keynotes and sessions and networking, and make sure you wear comfortable shoes. All really great advice for GTC. So especially
I think wearing comfortable shoes is the key part.
Yeah, definitely. Bring your notebook and water. Yeah, but if you're going to GTC, it's a really fun time, and I do hope that that some of the people here watching this are able to attend. If you're not able to attend, all of the or not all, but a lot of the sessions are recorded, and you'll be able to watch them afterwards. And like Zach said, we do have a lot of NIM related GTC sessions, so definitely recommend checking those out.
There's also virtual registration too. So for people who can't show up in person, you can register and attend virtually. Yeah. If it's a little too far for you to come. And also to add to that, the us having this live stream is really for the audience, you folks attending. So we encourage you to ask questions. We might bring one or two of them up and have Neil or Chris answer them in this stream. So, or maybe 3 or 4. So please, ask away. Also things like, if you have experience using our API catalog, Nim in general, or perhaps some other NVIDIA technology that's your favorite, leave us a comment what it is.
Yeah, definitely. Would love to hear from you guys, and please ask questions. We love to answer questions.
We eat questions for breakfast.
Yeah, absolutely. Okay, one other thing that I wanted to show on this API catalog, which you may not have seen before, is this blueprints tab. And what these blueprints are is basically, if you just have a single model, it can be, it can be fun to play around with, and you can, sort of ask it questions and things like that. But where these models really start to shine is when you start incorporating them into little more advanced workflows, things that are built for, a certain specific output. And that's basically what these blueprints are. We've sort of taken all of our NIMs and built out these workflows and given examples of what you can do with NIMs for various different things. So, for example, one of our featured blueprints is this PDF to podcast blueprint, which Chris is going to be telling you all about in a little bit. But there's also plenty of other ones. So we have this PDF data extraction, container security, building a virtual assistant, building a digital human. This one's super cool. And so definitely also encourage you to check out all of these on build.nvidia.com. If we click into, which one should I click on? Let's do the multimodal PDF extraction. We have this information here about which NIMs, basically which models are included in this blueprint. You're able to see the source code on GitHub, which basically explains how you can deploy it in your own environment. And we also have this cool deploy launchable button, which will basically spin up a environment for you in the cloud that you can use to deploy all of the components of the blueprint and just really quickly get started using the NIMs. If you saw one of our previous live streams, we actually went into Launchable and the Launchable platform and sort of how you can use that. So another really cool feature of our API catalog and something that I really hope that you take advantage of. Okay. I think that covers a lot of what I wanted to talk about sort of introductorily. That's a word.
It can be.
Yeah. Let's see. Should we answer a couple questions? I've seen a few come in the chat. Okay, here. PDF data extraction. That assumes the PDF document has set form fields with or without text. It's actually a little bit more robust than that. So basically it's able to handle all sorts of different PDF layouts. So whether it's got form fields or whether it's got like diagrams or just free text or all sorts of different things. And that's why it's got all these different models associated with it, because basically all these different models are handling different kinds of PDFs that have different kinds of data. And so it sort of takes those PDFs and converts them into free text, which is a great format for doing further processing or using it in a retrieval augmented generation system or incorporating them into LLMs and for training and things like that. So it's basically able to handle all sorts of different kinds of PDFs. It's really robust to all sorts of different formats, which I think is super cool and very useful. So yeah. Okay, is it in the cloud? Do we have an opportunity to use it with a smartphone?
So I would say not directly, but the launchable does allow you to spin up an instance in the cloud, which you can then interact with through potentially a smartphone. It's not like optimized. There's no like beautiful, responsive UI that you're going to be able to leverage, but certainly you can host it in the cloud and then you can access it as you would any other cloud resource.
Yeah, and one of the great things about these blueprints, I mean, we don't necessarily intend for these blueprints to be like a final product that you sort of use in your day-to-day life. That's why we open source them and share the code and sort of give you all sorts of examples for how to deploy it in your own environment. The idea is for you to sort of to look at the components that are part of these blueprints and kind of build off of them and customize it for your own applications and sort of see what's possible with large language models and generative AI. So if you wanted to build something for a smartphone, I think it would be really great to sort of look at what's going on in the blueprint. Open up the source code and see all the the documentations and the layout and everything, and see how you can convert that into models that you can use on your smartphone, or at least like a UI that you can use on your smartphone. So yeah, it's a great question, but this particular example is in the cloud and not on a smartphone. Okay, awesome. Okay, another question. Do you have distilled versions of DeepSeek to be used in a desktop or laptop with an NVIDIA GPU? We totally do. What a great question. Let me see if they are up here on the API catalog. It looks like the API catalog itself doesn't include the distilled versions, but we do have NIMs for some of the distilled models that the DeepSeek put out, the Llama models, and I think maybe one of the Quen models too. You can find those on NGC. Doing some live searching. I think we have one out right now, and there's going to be more coming in the future, if I'm not mistaken. So let me see. Yeah, here we go. So we have the DeepSeek R1 Distill Llama 8B, which is an 8 billion parameter model. Let me zoom in a little. Which is obviously much smaller than the full DeepSeek, which is like 600 billion parameters, and definitely will not fit on any laptop. Whereas this 8B model, can fit on laptops that have a decent amount of GPU memory. So, yeah, you can take this and download it and run it on your laptop. It's great. Yeah. For DeepSeek, you need a lot more than a laptop GPU.
Just a bit. Just a bit.
Just a bit. Yeah. Yeah. Okay. I think we're good. So Chris, do you want to take over and start talking about that podcast?
Oh
stuff?
yeah. Yes. Okay. So we heard from Neil about kind of what is going to get us to power the thing, to act as a reasoner to produce, our final product. Now we're going to go ahead and look at what we're going to be building today. So if you want to throw my screen up there, Zach, we can rock into this. So we're going to be looking at the PDF to podcast blueprint. So this is a blueprint, just like Neil described. The idea of the blueprint is to give you a blueprint, right, to build something on top of. So it does work out of the box, does cool stuff, but it's meant to be tinkered with. It's meant to be, adapted to your use case. Very, very exciting stuff. Okay, so once again, we have kind of this blueprint card that Neil's showed us. It goes over all the licensing, the models, everything you need. It's got a sweet diagram. It's also got the view source code button. That's what we're going to be looking at today. And of course, you can deploy it as a launchable. So let's look at the diagram for the blueprint we're going to be using today. So this is the diagram for the PDF to podcast application. The basic idea here is that we're going to ingest some PDF as well as some optional PDF context. We're going to use dockling to parse that PDF into a more suitable or consumable format. And then we're going to use this kind of, flow in order to construct a transcript for a podcast. So what we're going to do is create an outline. So just zoom in a little bit there so we can see it better. So we're going to create an outline. We're going to structure it. We're going to segment it into different transcript sections, do some deep dives, use some transcript optimization, podcast dialogue generation. This is like the back and forth classic stuff. Then we're going to start fusing these things together so they make sense in between chunks, do some revising, and then once again, go back to our evaluation of the total transcript and potentially do some iteration here. You'll notice we see Llama 3.1 405B in a number of these Nim boxes that are powering some of these steps. These models are totally flexible, so you can use whichever models you wish. Today, we're going to be replacing that 405B with the build.nvidia.com endpoint that Neil showed us, which is a DeepSeek R1 endpoint. Okay, so once we have a finished podcast, all we need to do is send this to 11 Labs. 11 Labs is going to generate the actual audio for us, and then we can listen to our newly constructed podcast. Again, this is using dockling on the back end to parse those PDFs into a more consumable format for the LLM. This is an integral step, right? But again, this is a blueprint. You can change this with whatever pipeline you have for a PDF extraction or file extraction or what have you. Again, these are designed to be played with and modified. So let's look at the actual repo with the source code. So you see it's got everything that we'll hope for in a repo. It's got, all of the resources we need, exactly what we're going to use out of the box, what services we're going to use, what kind of hardware we need. If we're running this locally, then we need to support all these models in our environment as well. But we don't have to run them locally. We can point to build.nvidia.com for that. And then it shows us a quick start guide. So we've done some of this ahead of time just to be able to save you guys a little bit of time watching loading bars. But the idea is that we have to have Docker. Once we have Docker, we have to get some API keys. Once we have our API keys, we're good to just clone this repo, set those API keys up, and then we're going to install our dependencies using UV. And then we're going to move to the next section together with make all services. Excellent question in the chat. Is it open source? Yeah, you can use it. You can contribute to it. We love you to leverage this as best you can. So what is actually powering this thing, right? So we see that, yes, it is a pile of code, right? But what is the pile of code? This is, again, totally visible to you, right? So it's all released. You can play with it. You can do whatever you'd like. But you'll see that we have a number of different services that we're going to consume. So we've got our API service, our agent service, our PDF service, and our text-to-speak service. The agent service is probably the most interesting because it's the thing that gets us to the podcast, right? So that agent service is everything that's happening in this box here, right? That's going to actually generate our podcast. So what we can do is look into exactly what's happening in this agent service. Like, let's look, for instance, at the podcast prompts to see what kind of prompts are leading to this final output that we're going to listen to together. And you'll see that they're totally visible prompts, right? You can play with these, you can change them, you can make them whatever you want. Every prompt that is used is going to be provided here, and you'll see that they're quite verbose. They're well set up. But the idea is that these are completely flexible, right? So the podcast that you hear today is going to be generated using these defaults, but feel free to change the prompts, change the characters, how they should interact, change the amount of time you want to spend listening to the podcast, etc. All totally under your control through these services. We'll also look at the actual thing that makes it go, right? So you'll notice that this is basically just using a simple kind of Lang graph application. So what we're going to do is we're going to have our different nodes that do different jobs, and then we're going to build a Lang graph application that connects all of these nodes together. So the prompts are open, right, and consumable for you. Everything is open and consumable for you. You're able to change any of this, right? That's happening under the hood. You're able to change the way that it's stitched together. You can do that all. Very, very fun. The podcast that we're going to generate today, just to be a little bit meta and have some fun, is going to be a podcast that talks about the DeepSeek R1 paper. So we're going to use that as our source PDF. This is just to use the DeepSeek model to make a podcast about DeepSeek. It's just fun. Okay, so what I'm going to do now is I'm going to switch to my VS Code screen for you guys, and we're going to go ahead and we're going to do that here. And then I'm going to ask Zach to share that for us to see. Perfect. Thank you, Zach. And you'll notice that we're already in the PDF to podcast repo. So I've already cloned it. I've already got Docker installed and ready to rock. I've already got things set up on that end. What we're going to do now is just take a little, again, peruse through the repo. You'll see we've got a number of different folders, a number of different things that we can do. The important one for the test case is the samples. So this samples, directory is going to contain the PDFs that we care about, that we wish to use as context for our PDF to podcast application. So I've uploaded I've put the DeepSeek R1 PDF in this samples repo. You'll also notice that we have this tests. So tests is where we're going to kind of save all of our podcasts that we generate. You'll also notice that we're going to use this test.py. So this test.py is the thing that's actually going to give us our podcast. So it's how we're going to generate the podcast. Again, you can use you can use this service however you like, but this is definitely the first thing you should try, right? You'll notice that we assign random speaker names, so you can change these speaker names. As you'll see in the example, we use Bob and Alice because it's classic, Alice and Bob, right? All this is doing is it's consuming the actual services that are going to be built when we do the make all files that we're about to do. Okay, so we've got our test kind of PY that we're going to use. We've got our services, everything kind of finished to this step. What we're going to do next is we're going to use make all services. This is going to actually get things up and running. So I'm just going to clear the screen, and then we'll do a make all services. Now, the first time that you run this, it's going to take a little bit longer. This is because we have to download the Dockling model, right? Which takes some number of gigabytes. But you can see pretty straightforwardly that once you have that done, the service is up and running, ready to be consumed extremely quickly. What this is doing behind the scenes, right, is it's loading all of these different services in concert through Docker Compose so that we can consume them all in a way that results in us having a podcast. So the next thing that we're going to do is, I'll talk about this briefly, but we have kind of like two things that we can play with, right? So we have our .env file, which is where we put our API keys. Remember, because you can customize this, you can put kind of whatever things that you want in these through these APIs, right? So if you want to use like OpenAI or Anthropic or whatever have you together, it doesn't matter. You can put these in, and then of course for 11 labs, we're going to provide our key as well. And then we have our models.json. Now this is like the most important part, quote unquote, because this is the part where we choose which models we want. So you'll see here that we've got our DeepSeek R1 model, which is going to be through this API that you can find from build.nvidia.com. This is like the only change you need to make is this, and then it's using DeepSeek, right? So if that's all you did, then you're generating a podcast with DeepSeek. You don't have to do any other steps. The rest is just like what we've already shown, right? But you can also change our JSON file, our model. It might make sense to you, but the idea is that this should be a model that supports JSON mode, right? So you can use any model you want, so long as it supports JSON mode. And then we have our iteration model. This model should also support tool calling in order to make the flow work. This reasoning model, though, it can be whatever you want. Choose your favorite reasoning model and pop it in. Okay.
Before you move on for this,
Sure.
just the NVDev thing. That's an internal thing for us at NVIDIA. If you are following this blueprint, just leave off that NVDev kind of prefix for the model name. So it should just be Meta Llama 3.1. But everything else you should be able to do exactly the same from wherever you are.
Yes, and great point, Neil. You'll just take these right from build.nvidia.com. So exactly as you see those addresses on build.nvidia.com is what you should put in this models.json. Excellent point. Yes. Okay.
And if you have your own NIMs deployed locally, for example, like if you're deploying them in a data center, or if you have them on your own, your local machine, like on a laptop or something, this would be where you would modify that as well, so that you can point them to your local machine.
So basically, depending on where you've hosted it, obviously, but you just need to change your API base, so where the endpoint are hosted, and then you need to make sure that that model is available on that endpoint, so that you've deployed it just as Neil said. The idea being that this models.json is really all you need to touch to change any of those things, right? So as Neil mentioned, if you've hosted NIMs, if you want to use different models from build.nvidia.com, all we're doing is we're editing this models.json. We don't have to do anything else, right? There's no additional steps for us in order to make that work, which is fantastic. So you can get experimenting and playing around very quickly. Okay, so we're going to use DeepSeek AI's DeepSeek R1 to create the initial kind of transcript, to parse through the document. That's going to be fun. And then we're going to use just our classic, llama models to do the rest of the work. Workhorse models, so they're going to do the work. It's going to be great. Okay. So the next thing we need to do after we have made all services is we're going to go ahead and we're going to actually generate the podcast. So what we have to do is head to our terminal here. And what we're going to do is we're going to use the first command to activate our UV generated VM, make sure that that's active. And then we can go ahead and we can use our Python, tests/test.py. Our target's going to be the DeepSeek R1 PDF. There's a bunch of additional flags that you can add here. So we can use the monologue flag. We can use the context flag. If we look in the actual test script, there's a bunch more options that we have access to, where we can actually change, the number of people in the podcast. It's all available in this kind of, test.py file. So you can choose the names right from the command line. You can choose the duration, the target duration of the podcast. It's all available to you in the test.py file, and can be leveraged to great effect.
So I'm curious about one thing. Have you tried out with like multiple different speakers or with one speaker? Like what has worked the best in your opinion for those?
Yeah. I like so works the best is an interesting question. So they all work suitably well, right? So especially depending on the model composition. So like R1 plus the 8B and the 70B is a great combo. It generates coherent podcasts every time. I'm not a big fan of the monologue because I think the back and forth, like but that's a subjective thing, right? I mean, the quality, as in, does the generated podcast stick to the context well? Does it cover the key parts of the PDF, for example? Like that's not really changing a lot, or at least in the testing that I've done, it doesn't really change a lot between monologue mode, multiple speakers, all these other configurations. Like it's all good. Just lit for like listening fun though. I enjoy having the back and forth, especially if you choose like 11 Labs voices that you like. So you can actually set the voice IDs, right? So if you have like favorite 11 Labs voices, you can choose those directly as well through that test.py or the command line, and that is extremely fun. But yeah, I like again. They're all high quality according to the testing, right? They stick to the script. They do a great job. They don't hallucinate a lot. But I just like the back and forth. I love it. Yeah.
Got it. Yeah, I feel like it'd be really interesting to have like 10 speakers and just like a huge cacophony of people talking to each other. I don't know. Might be fun.
I do believe it would be fun. It might lose my mind a little bit, but I do believe it would be fun. So this is Ubuntu only. So you are required to have Ubuntu 20.04, 22.04 with sudo. You can run this on Windows, as evidenced by the fact that I'm currently on Windows through WSL2. So it is possible to run this without problem on WSL2. Which means that it's open to Windows. I've not tested it on a Mac, but the system requirements do say that it's for Ubuntu. So I would stick to those to try it first. But again, WSL2 is doing a good job, as we can see by it motoring here. Okay, finally, we will click the button that makes it go. So we submit the job. We have our test.py. Our target's going to be DeepSeek R1.pdf. And you're going to see it's going to start chugging. You're going to see that we have this, this kind of log that we can view through the Docker container. So it's going to tell us what's happening when. It doesn't work the same as OpenAI and ChatGPT, which is a foundation model. Any particular ML is trained on. So this is leveraging a number of models. So it's not a specific model. So if we go back to our models.json, basically, this is leveraging these three models. So what that means is that it's not using like a specific trained model for this task. It's just using a combination of models that can handle this task, which is what we would hope for. We also have a question: can you use open source voice model clones instead of 11 labs? How much? Oh yeah, if you want to, for sure, right? So this is the beauty of the blueprint, right? This is the thing. So you see in our services, we have our agent service, we have our API, and we also have our TTS service. So as long as you're able to adapt to the expected inputs and outputs that are present for the 11 lab service, you can just straight shove whatever you want, like in the place of that 11 lab service. So long as the API is the same, right? It's going to work relatively out of the box. If the API is different, it's going to be a bigger lift on your end, right? You're going to have to do more coding, basically. But the idea is that this is totally adaptable to whatever you're using. All this code is editable for you. Again, if the APIs line up, it'll be easier, but it's certainly possible to use any voice service you want, any voice model that you want, so long as you can adapt it to the expected inputs and outputs from this blueprint. Yes, you can change all of it if you want. You can change the agent pipeline, right? You can change the way we ingest documents. You can change anything. Totally up to you. And in fact, please do, right? We encourage you to. We're providing this as a base for you to make cool stuff with, right? Not like this isn't prescriptive. It's not like this is the way you should do this. It's like, here's a way you can do this. Please tinker with it, play with it, and make it suit your needs the best. Okay, so we're gonna do a cooking show movie magic right here. So the service takes a little while to complete because the endpoints that we're leveraging today are not the fastest in the world. So we're gonna do some, again, movie magic. So what I'm gonna do is I'm gonna stop sharing my screen. That was it, by the way. Just to be clear, this is once we've done make all services and it's up and running, we just have to submit this pointing at the PDF we want to podcast of. That's it. That's the demo. Good job. Okay, so now we'll fast forward using movie magic to a completed podcast, and I'll go ahead and share my screen again. Zach, if you wouldn't mind loading this up. We're going to listen to like 10, 15 seconds of this podcast, not the whole thing, but just to hear kind of what the final results are going to be. So this is generated with DeepSeek R1 with our JSON model being Llama 8B, and then our revision model or edit model being the 70B. Okay, so we're going to listen to it.
Welcome to our show today. I'm your host, Bob, and I'm excited to explore the cutting-edge DeepSeek R1 model and its advanced reasoning capabilities. I'm joined by Alice, an expert in the field. Welcome, Alice.
Thanks, Bob. I'm excited to share my insights on this powerful model.
So let's dive right in.
There you go. It makes a podcast, right? That's the thing it says it would do, and it did it. The length is variable, so you're typically going to get between like a 4.5 minute podcast, like a 9-ish minute podcast. There is some tinkering you can do to the test.py file along with the services files to try to force the length to be more specific. I've found that you got to give yourself like 2.5 minutes leeway on either side, right? It's going to get close, but it's certainly not going to get like exactly 5 minutes. But they do the whole podcast thing, including like a sign off, right? So we'll just listen to the very end just to hear
NVIDIA AI Foundry and Nemo software to learn more about customizing.
All the time we have for today. Thanks for tuning in, everyone. If you want to learn more about
it, right there, you go. It's a real podcast. Yeah, and that's the thing. That's what it does. PDF to podcast. It makes podcasts for PDF. There you go.
All right, fantastic. Thanks, Chris. That was really exciting. Does it work with multiple podcasts, or can you only use one at a time?
So you can add.
Or not multiple podcasts. Sorry, multiple PDFs. Multiple PDFs.
Yeah, totally understood you. So you can add additional PDFs as context for the initial PDF. So basically, like there is going to be a main PDF, but you can supplement that with additional context. Like say for instance you wanted to do DeepSeek plus news around DeepSeek, etc. You can provide that in PDF form. Yeah, absolutely. Yeah, can they go beyond the scope, delve into different topics, or at least yes. So yes to the second part. They definitely try to be funny from time to time.
How successful are they at trying to be funny?
I would say like as successful as normal podcasters.
Yeah, okay, that's pretty good.
But they don't usually go off script. Like they might do like a small tangent, especially in the close. They tend to do like a tangent about the actual podcast that they're hosting. But for the most part, it stays extremely on script, which is desirable, right? Like we want them to stay on script. You can introduce noise in your context, and that will cause them to go more off script. So if I do DeepSeek as my PDF and then I add like a PDF about nachos or something, like they will talk about nachos, right?
Getting hungry.
Yes. Okay. You can string all the PDFs together, upload them as one document, sure, but remember that the model has to consume all of this. So there's an upper limit, right, to how long your PDFs can be, and also remember that a lot of that context is going to be it's going to slow the process down, let's say, right, and most importantly, you're going to lose some information. So it's always going to be compressing information. It's always going to be, going from PDF to a 5-minute podcast. And so if you have 70 documents in a chain and you haven't exceeded the context limit, you're likely to lose a bunch of information and context just because the podcast is only 5 minutes or whatever. Yeah.
Great.
Can you do something with computer vision? Not immediately, but there's examples on the API catalog with a couple different models that use computer vision. Most of them I think are multimodal LLMs. I don't know if we have like a dedicated ResNet or something up on there. Maybe I can check that out. But yeah, there's a bunch of models that can analyze images and tell you what's going on in the image and sort of do visual question answering and things like that. Even the PDF ingestion model that we talked about uses computer vision to understand diagrams and the layout of the page and things like that. So yeah, definitely do things with computer vision. It's great.
And there's a blueprint as well, which is for video search, right? So there's blueprints, like Neil already mentioned one, but there's a bunch that cover a wide variety of modalities. Can it talk in different languages? So not out of the box. So it's English out of the box, straight up. It points at English voices. It uses English transcripts. But again, if you substitute in models or you change the prompts or you tinker with the system, you can certainly you can make it talk in whatever language is supported by text to audio, right? So your text to speech models, and as long as your core implementation is adapted to make them produce transcripts in whatever language you desire, then yeah, you can make it whatever language you want. Out of the box though, it is English. Yes. Motion performance training with yes. Okay, so so again, a lot of these questions are going to be answered the same way, which is that you can inject this information in your flow if you want. A lot of services like 11 Labs actually they provide an avenue for you to choose the emotion, right? So you'll notice that the podcast voices we listen to, they sound excited at times, or maybe what's going on, incredulous, but this is something that you'd have to change. By default, we're going to generate those as part of generating the transcripts, and then 11 Labs is going to handle that. But you can inject emotion as you desire based on the API you use. 11 Labs is one of the APIs that allows you to do that. Yes, you can make a longer than 5 minutes podcast. I would though remind you that you're paying 11 Lab credits for the default experience, and going much longer, you're going to run into credit issues. So, but you can make them as long as you feel are necessary
Yeah,
up to
and
10 minutes.
and that might be a great use case for using your own open source text to speech models, right? Which I think we have some available on the build as NIMs on the platform as NIMs. But yeah, the 11 lab ones are also really good. So
Yes. Can we also train your model on custom data sets? The answer broadly to this question is yes. In terms of this, there's no specific model training or data set that you're going to get out of the box, but you can certainly use like a fine-tuned model to power the podcast if you've got that set up. Yeah. Great questions. Great questions.
More questions.
Oh.
Like new learners of Python or like new learners of like deep learning? Because I feel like those are very different questions.
I'm guessing it's probably the new learners of Python, but it could be
Ooh.
wrong.
I don't know. That's a great question. I'm not sure that I have any advice on this one.
Chris, what about you? What's your favorite?
If you're gonna start with Python, I know the book's got to be like 40 years old or something like that. I don't know if that's really true, but automate the boring stuff is always a fun way to start with Python. It kind of gets you in the mindset of what programming is useful for. It keeps you on track. If you're going more from the deep learning side, then like Sebastian Rashka has a book called Building LLMs from Scratch, which includes some Python that I think is useful and fun.
Yes, that is a great one. And yeah, he just responded. He meant deep learning, or they meant deep learning. So yeah. Yeah, I think Sebastian Rashka's book is really good. If you want like more like theory stuff, Elements of Statistical Learning is a great book for like learning a little bit more about the underlying principles of deep learning. So yeah, two great options there. And I think Elements of Statistical Learning used to use R, but they put out like a new version recently that uses Python. I haven't looked at the Python version. I only use the R one, but I've heard it's good. So you should check it out.
Can you combine the PDF extraction model and the podcast model together? So you extract data from the PDF, then create a podcast. So that is what's. So I think if what you're asking is, can we go straight from extracted PDF to podcast? Then this system does not do that. You could probably build a model that would do that. It might take you some time, but in this case, we do rely on these models being specialists. Basically, having a model that's good at creating these long form plans, and then models that are good at executing on those plans. So that the ensemble here really does add value. Yeah.
Great questions. Oh, and there's more.
Oh yeah. So it dumps everything into the logs in the containers, so you can get a bunch of raw. You can get the raw transcripts. You can get the raw voice. You can edit it however you want. Yes. Again, this is going to require you to move beyond like test.py, right? But you can certainly edit the transcripts. There's a full. When you do make all services, there's a full API, like a docs page, classic like Swagger docs page that will give you the different endpoints that you can use and consume. But yes, you can hack into any part of the flow.
All right.
Great questions. And more questions.
Okay.
How long does it take to generate the podcast? And could you optimize how long it takes to generate?
So it's all dependent on your endpoint, right? So the faster your endpoint is, the easier it is to generate podcasts, right? Reasoning models are going to take longer because they love to do this thing where they spit out tons of tokens, right? But optimizing the podcast is by doing things like using NIMs, right? Like Nim is an excellent tool. It produces a lot of tokens very quickly. But basically, you're looking at model selection and inference solutions being the levers you can play with to get podcasts faster. For the testing we did, it took anywhere between, for me, it took anywhere between 5 minutes to 14 minutes to generate a podcast.
Great. Well, we have actually a question from one of the other platforms. Can't really bring it up on screen on this end, but it's pretty straightforward. It's asking, or they're asking, can I deploy Nim in public cloud like Google Cloud, AWS?
Yeah, absolutely. You can deploy it anywhere. Well, anywhere that there's a GPU, which is I think one of the really great things about Nim. So you can deploy it in Google Cloud, you can deploy it AWS, you can deploy it locally on your own machine, you can deploy it with our launchables that we have some examples of on the API catalog. There's all sorts of places that you can deploy NIMs, and so yeah, just go forth,
Go forth and deploy.
Yeah,
And
exactly.
what's the cost?
For the NIM itself, you can download it for free through the developer program. So you just have to join the NVIDIA developer program, and you'll get like free access to download the NIMs. In terms of like the hardware cost, it depends very like a lot on which model you're going to use. For the smaller models, you can deploy them on small GPUs, and so it's not very expensive. For like the really big models, like the DeepSeek R1, you need a lot of GPUs, and so it can be a little bit pricey. But yeah, just you can find the models that work the best for your budget and for your use case.
Great. We actually have our developer Discord that people here can continue the conversation after the stream and going forth in the future. Appreciate if our mods can throw that into the comments, or if you have already, thanks. Should direct people, and you can keep chatting away at any time of the day or night.
Alrighty.
Well, great. Well, so we put up this last slide again. Magically threw in a GTC discount promo code that we just picked out of the air just for this audience. So if you want to register for GTC, come join us. It's happening in 2 or 3 weeks. It's coming up pretty quick. I know hotel rooms are pretty hard to come by, but I'm sure you could find something to shack up somewhere. But we'd really appreciate seeing you there. Come find us any sessions that might interest you from any one of our various technology verticals. Join us virtually if you can't make it in person. And we look forward to seeing you on a future developer live stream.
Yes, and we will also be at GTC. We have a Connect with the Expert session at GTC. You can come by and ask us your questions in person. So yeah, please come through. We would love to see you guys in person.
Yep. Yeah, thanks, Chris. Thanks, Neil, for joining us on the stream. Hopefully we'll get you back. I'm sure we will. Thank you, everyone here, for joining us, and we'll see you on the next one.
All right. Thanks, Zach.
All right. Thanks, guys. Thanks, everyone, for joining.